Okay, we should be all good. It's going live now. All good on the volume? Yeah, okay, good. We're all good on the volume. So let's get into it. So we did functions, or we ended off last stream with going into functions. We've done some functions obviously in the past, so yeah, let's get into it. So lesson 11.11. I'm pretty sure I've already done chapters. Yes, I have. So function overloading templates. Okay. So, introduction to function overloading. Okay. Just checking everything's all good. Yeah. Yeah, is my audio good? Yeah. Okay. So, function overloading. Consider the following function. We got a return type of integer, add, and then we're passing in the parameters of int x and int y. This is a trivial function, so I'm not going to personally write this out, but what if we wanted to add 2 floating points? The add is not suitable because we're doing we've got an integer as a return type. One way to work around it would be to do an add double. So, intro to function overloading. So long as each identically named function has different param types. Each function sharing a name in the same scope is called an overloaded function. Overload for short. So we basically, for example, these functions. So we had int add with a int x and int y, and in the block we returned x plus y, and then we had a double return type of add double, and then we had int x and again int y, and we returned x plus y. So would become, so int add would be the same, int x, int y, so that should be double. And then you're returning x plus y. And then our double will be double add. So what is the difference? Oh, the function name is the same. We're returning x plus y. And then our return type integer would just be, and I assume we would just call add, something like or something like that. Okay. So, introduction to function overload. Resolution. So you got so yeah, let's copy this. Oh, that's because that should be y. And then if we ran that, and then we ran, see, look, we have an option to do double, or we have an option to do add. And then we do 1.2, 1 3.4. And then if we ran that in our terminal, yeah, we get 5 and 4.6 as we would expect. Cool. Nice. So now what we'll do is what happens if we did just 3? No, so you have to do that. Yeah. So making it compile. In order for a program to compile, we must have two things. One, each overload function has to be differentiated from the others. 2, each call to an overload function has to resolve the overload function. If an overload function is not differentiated, or a function call to a overload function cannot be resolved, then the compile will result in an error. Okay. Function overload differentiation, which is what this is. Each function must be differentiated from the other. if we just do that, yeah, cool. So the name of parameters and parameter types help differentiate our function overloads. Yeah, cool. So that means then note that a function of return type is not used. Yeah. Overloading based on the number of parameters. So an overloaded function is differentiated so long as the overloaded function has a different number of parameters, as we learnt here. For example, int add, int x, int y, and then we're returning x plus y, and then in our int add int x, int y, int z, and then we're returning x plus y plus z. So you can see here we have 3 parameters here and 2 parameters here, allowing the compiler to differentiate between the 2 adds even though the function name is exactly the same. Yeah, cool. Overloading based on type of parameters. A function can also be differentiated. A function can also be differentiated so long as the overloaded function list has distinct parameter type. For example, we got an int double, int, and then so all of the function names are add, and we got double x, double y, double int xy. Yeah. Because all the aliases or type defs are not distinct types, overload function using type aliases are not distinct from overloads using alias type. So you got a type def int height. So I think this would be best if I actually, so type def int height using age equals int. So this is a type alias, and this is a type def. So you got a void print int value, and you got a void print age value, which means this and this is the same because age is an int. Then you got a void print height value. Yes. Okay. For parameters passed by value, so the parameters have to be different no matter even if you use type aliases or type defs or const. The return type of a function is not considered for differentiation. Yes. So it's only the parameters that are considered. And the fact that when you call it, it has to resolve the parameters of the function. So just because it's an int and this is a double doesn't necessarily mean that they are differentiated. Okay, type signature. Okay. Function overload resolution and ambiguous matches. So this is all about the call. In simple cases, where the type of the function is usually straightforward. So for example, if we had a void print int x and then we had a standard character output of x with a line break. And then we had a void print double D, and then we had a standard character output of D. And then in our main, we had print 5, print 6.7, and it matches that because this is an integer, and it matches that because this is a double. That makes sense. So this is all about function overloading. But what happens in cases where arguments in the function don't match? So let's find out. So let's actually so we got a no, print. We're going to do 5 and then print. So actually, no, what we want is we want 5 long, and then we want a character of A. So we show errors. It's ambiguous, and we require either a double or an integer. So resolving overload function calls. When a function call is made, To a overloaded function, the compiler steps through a sequence of rules to determine if any of the overloaded function are the best match. At each step, the compiler applies a bunch of different type of conversions of arguments in the function call. For each conversion applied, the compiler checks if any of the overloaded functions are now a match. After the different type of conversions have been applied and checked for matches, this step is done. This will result in three possible outcomes: no match, a single match, more matches were found, creating ambiguous. If the compiler reaches its entire sequence without finding a match, it will generate an error. That makes sense. Because the arguments you pass in must match the parameters. So, the argument matching sequence. So, step 1, the compiler tries to find an exact match. This happens in two phases. First, the compiler will see if there is an overloaded function where the types of the argument in the function call matches exactly with the params of the overloaded function. That makes sense. For example, this. Second, the compiler will apply a number of trivial conversions to the arguments in the function call. The trivial conversions are a specific set of conversion rules that will modify types for purpose of finding a match. These include the L value to R value conversions, qualification conversions, non-const to const, non-reference to reference conversions. So for example, void const double. Double and is a reference to a double. So int x foo, x trivially converted from int to constant, double d 2.3. The true converted from a double to a const double. In the above example, we called foo x, where x is an int. The compiler will convert int to a constant, which then matches const int foo. We've also called foo d, d is a double, and it will convert to a const double. Matches made via the true. Step 2. If no matches are found, the compiler tries to find an ambiguous. Yes. So that's promoted to A because that'd be 97. This is to be converted to true integer because true is 1. And this would be promoted to a double. That makes sense. So, step 2. If no exact match is found, the compiler tries to find applying numeric promotion That makes sense. Okay, then step 3. If no match is found via compiler tries to match by applying numeric conversion that we learned last stream. Step 4. If no match is found via numeric conversion, the compiler tries to find find a match through any user defined conversions. Steps 5. There are 6 steps. If no match is still found, the compiler will try to find a match using ellipsis. Then step 6. If still no match, the compiler gives up and issues an error. Okay, I'm just going to take a quick break here and I'll be back in a minute. Okay. Right. So where were we? Right. We're still good on the audio. Let's just have a look. Yeah. Okay. So we'll probably go for about another hour until about 12:30. Yeah. So ambiguous matches. So yeah, about another hour. So with non-overload functions, each function will call with either resolving a function or no match. Yes, that makes sense. With overloaded function, there is a third possibility of an ambiguous match. ambiguous match occurs when the compiler finds two or more functions that can be made to match in the same step. Remember the steps that we learned about here. Since every overload function must be differentiated in order to compile, you might be wondering how is it possible for a function call could result in more than one match. Let's take a look at this. Since a literal 5L is a type of a long, the compiler will see if there is a match for a long. It will not find one. Next, the compiler will try numeric, but values of long can't be promoted, so there is neither match here. Fortunately, the compiler will try to find a match by applying numeric conversions to long argument in this process of checking numeric conversion rules. The compiler will find two possible matches. If the long argument is numerically converted to an int, then the function call will match int. If the long is passed to a double, then it will match double. Since okay. Resolving ambiguous matches. Because ambiguous matches are compile time errors, an ambiguous match needs to be disambiguated before your program will compile. There is a few ways to resolve ambiguous matches. Often the best way is to simply define a new overload function that takes the parameters you're trying to call. Alternatively, explicitly casting ambiguous match arguments to match the argument here via static cast. If your argument is a literal, you can use a literal suffix. Okay. Matching functions with multiple arguments. If there are multiple arguments, the compiler So if there are multiple arguments, the compiler applies matching rules to each argument in turn. The function chosen is the one for each argument. The function chosen is the one for which each argument matches at least as well as the other functions, with at least one argument matching better than the other functions. In other words, the function the function chosen must provide a better match than all the others. In this case, in the case that such a function is found, um, is found, it is clearly and unambiguously the best choice. If none is found, it will be considered unambiguous. That makes sense. For example, this. So you've got a void print char int parameters, and you're printing out A. Void print char double, you're printing out B. Void print char float as parameters, and here you're printing out X and A characters. So you got the char here as this, and then you're doing another char, but because char is not possible for your argument, so your second argument, it will find the next alternative. Now we know that A in ASCII is 97, so we know that float, it won't be float, it won't be double, so it'll be int. Cool, that makes sense. Okay, deleting functions next. So we'll probably end up going for about another hour. So how long have we got left on the functions? Okay, so we'll probably get maybe to function templates, depending on how long deleting functions are and how quickly we get through it. But that doesn't mean we're rushing through it because we need to learn. So a default, default, my bad. Default functions, not deleting. A default argument, no. Is that what we're on? No, we're on deleting functions. Yes, I was right. So, deleting functions. In some cases, it's possible to write a function that won't behave as desired. When called. For example, you got this input-output stream header. We then have a void print int, and we're printing X. We're printing 5, which is fine. We're printing that, which is fine. And we're printing 1. deleting a function using the delete specifier. In cases where we have a function that we explicitly do not want to be callable, we can define function by using the delete specifier. If the compiler matches the function call to be deleted, the compiler will be halted and the compilation will be halted to a compile error. Here is an update. So I'm actually going to write this myself. So include our input output stream. Include is a preprocessor and the input output stream is the header. Yeah. Okay, that makes sense. So we got a void print int with a integer parameter, and then we're doing a standard character output x, and then we got a void print int char with a delete specifier. Calls to this function will halt compilation. Void print int double using the delete specifier. And then again, calls to this function will halt compilation. And that should be void. And then in our int main, we will print int 97. Then we will print int a. Then we will print int true. Then we will print int 5.0, and then we will return 0. So as you can see, function print int declared on line 8 cannot be referenced. It is a deleted function. And then same here, function print int double declared 9 cannot be referenced. It is deleted. It is a deleted function. So I'm just going to which one was it? It was char, which is this one. And then the double. Okay, that makes sense. Because this is printing a 97, this will print, because our argument is a char, we will delete it. This is true, which we converted to 1, a double, which is also a delete function. Okay. Deleting a bunch of individual functions works fine, but it's verbose. Deleting all non-matching overloads. So specify works okay, but can be verbose. There may be times where we want when we want to call certain function to be called only with arguments whose type explicitly match the function parameters. We can do this by using a function template, which we will learn in future lessons. So, I actually want to do that myself because I've never done a function template before. Void print int integer x standard character output x This is a function template. This function template will take precedence for arguments of other types. Since the function template is deleted, calls to it will halt compilation. This function will take precedence for arguments for type int. So we got a template, which is a C++ keyword. Then we have a type name, which is another C++ keyword. And then we have t. So void print int t x equals delete. So then in our int main, we will be printing int 97. Then in our print int a, and then print int true. This function print int tx with t equal char declared cannot be referenced. And the same thing with this. Print int tx with t being a boolean declared on line 12 cannot be referenced. Okay, so T is like T takes a type. Okay, so let me just copy that. And then what we'll do is we will move on to the next lesson. Default arguments. So default arguments. No, I do not want to save that. I'm just going to take a quick break here and we'll be back for the final stint. Okay, and we're back. Right, how is it on the stream? Yeah, good. Okay, so let's continue then. Um, okay, default arguments. A default argument is a default value provided for a function parameter. It's a default value provided for a function parameter. For example, void print int, and we have a int x parameter, and then we have a int y equals 10, and then we're doing a standard character output of x, and then we're doing a line break, and then we're doing a standard character output of y, and so 10 is the default argument. Okay, that makes sense so far. When making a function call, the caller can optionally provide an argument for any function parameter that has a default argument. When making a function call, the caller can optionally provide an argument for any function parameter that has a default type. If the caller provides an argument, the value of the argument in the function is called. If the caller does not provide an argument, okay, so when you call an argument, when you call a function, if the function has a default parameter, so you have a function, you have a parameter, you have a parameter, you have a default parameter as well, and when you're calling the function and you're passing in the arguments, you can pass in an argument for that default argument. But if you do not, the caller will use the default argument using the function. Okay, that makes sense. That does actually make sense. I had to think about it for a while first, but yeah, that makes sense. So consider the following program. So we have our preprocessor of include and then we have our header of input output stream, and then we have a void print, and then we have int x, and then we have our int x, and then we have a default argument of int y equals 4, with 4 is the default argument. Okay, that makes sense. So then, might as well just copy it from here. And then we do that. So then in our integer return type main function, we will be printing 1 and 2, and then another one will be printing just 3. So in this instance, y will be user supplied argument 2, and then y will be the default argument of 4. Now let me just, and then obviously a return type, return a 0. So just to prove that that is the case, get rid of that, bring all these in, bring in that. So we passed in the default argument here of 4. So that means that if we do not call, if in our calling of the function, our argument is not set for our y, our second argument or parameter, then it will return 4 by default. But if we do call an int in our argument for y, the 4 will be replaced by 2. So you'll get a result looking like something like this. x1, x2, which is, y2, which is this. But here we have x3 and y4, which is this. That makes sense. And I've already done it. So let me just reduce that. That makes sense. Okay, that's fine. I'm okay with that. So, when to use default arguments? So default arguments are excellent option when a function needs a value that has a reasonable default value, but for which you wish to let the caller override if they wish. For which you wish. For example, int roll dice, int side 6. So you may want the user to select the number of sides. Int open log, standard string file name default log. Okay. You're setting the file name to have a default argument. Okay, we've probably go for another half an hour. Okay. Default arguments are also useful where we need to add a new parameter to an existing function. If we add a new parameter without default argument, it will break. Yes, this can result in a lot of updating of existing functions. However, if we add a default argument, the, the current function we're using will be fine. Okay. Multiple default arguments. So a function can have multiple parameters with default arguments. So because we're learning, and I'm learning about default arguments for the first time, I want to actually code this little section myself. So get rid of this. We will include, we'll use our preprocessor and then the header. So we will do void print int x equals 10, int y equals 20, and int z equals 30. Then in our block body, we will be doing standard character output, and then we'll be doing the values. We will be doing x, a space, y, and z. Then in our return type integer main function in the block body, we will be doing print 1, 2, 3. And as you can see, when we're doing the calling of the parameter, our arguments by default are saying these are our default arguments, but they're allowing us to change. Then print, and this time we're going to do x and y only. Then we're going to do print 1, i.e. x. Then we're going to just call the print function. So this will print 1, 2, 3. This will print 1, 2, 30. This will print 1, 20, 30. And this will print 10, 20, 30. And then obviously we still need a return of 0. Hopefully that makes sense to you watching. And just to see that I'm correct, we get 1, 2, 3, 1, 2, 30, 1, 20, 30, 10, 20, 30. Cool. But you cannot do this. Let's just see if in C 2026 does. No, still not. Because we expect an expression. Okay. Okay, so next, what we're going to do is we are going to move on to where were we? So yeah, the notes now. C++ does not as a way to provide a default. As a way to provide while using. Okay, so this is a downside to it. There's three major consequences. So the first one is in a function call any provided arguments must be the leftmost arguments. Argument defaults cannot be skipped. So essentially what he's saying there is they must be to the leftmost, i.e. if you wanted X to be default and Y to be not default and X to not be a default parameter, you would need to make sure that X is the leftmost. For example, and let's just copy or not copy, but rather do this. Ourselves. So we got a include input output stream as always. Then we're going to have a void function print, and we're going to do standard string view with sv of hello, and then we're going to have a double of d equals 10.0. And then int main, and then we're going to do print. So that should print hello and 10. And then we're going to do print macaroni, which will be fine because our we're replacing this with we're replacing hello with macaroni, but we're still having 10. But and it will default to 10. But this of 20 will not work because we need to have a string. And it's basically saying we're trying to it's acting as though we're trying to convert a double to a string. So let me just copy and paste that. Hopefully that makes sense as to what we're doing with that. So then, so that's the first one. So 2, if a parameter is giving a default argument, all subsequent parameters, if the parameter is given a default argument, all subsequent parameters to the right. Okay. If a parameter is given a default argument, all subsequent parameters to the right must also be given default arguments. Okay. For example, this is not allowed. Then, if more than one parameter has a default argument, the leftmost parameter should be the one most likely to be changed by the user. Okay. That makes sense, and that is interesting, actually. Okay. Default arguments cannot be redeclared and must be declared before use. So once declared, a default argument cannot be redeclared in the same translation unit. This means for a function with a forward declaration and a function definition. And remember, a definition and a function are two different things. A definition has the squiggly brackets. A declaration doesn't have the squiggly brackets. So the definition is where you include in the body. The declaration is when you are making a call to that function. This means that for a function with a forward declaration and a function definition, the default argument can be declared in either the forward, okay, this is interesting, forward declaration or function definition, but not both. Okay. For example, so you got a preprocessor of include and our header of input output stream. Then we have our void print, and then we have a int x and int y being equal to 4. This is our forward declaration. And then we have our definition here, print, and then int x, int y equals 4. And then we have this is our definition, but will produce a compile error due to a redefinition of the argument. Also, the default argument must be declared in the translation unit before it can be used. I.e. must be declared before the int main function. For example, this would produce a compile error. Okay, nice. So the best practice is to declare a default argument in a forward declaration. The best practice is to declare the default argument in the forward declaration and not in the function definition, as the forward declaration is more likely to be seen by the other files. And included before, especially if using a header file. So for example, we have a foo header, and then if not defined, foo h, then we will define foo h, and then void print int x, and then we're passing in our default argument of int y equals 4, and then we end if. So that is our foo-h. Then in our main.cpp, we will include foo-h, and then obviously use a preprocessor including in for our input output stream. Then we will void print, and then we'll do int x, int y, and then in our body again we'll just print that. I'll just copy and paste like that. And then in our integer return type integer main function, we will simply print 5. So that means, that means our x will be 5 and our y will be 4. Okay. Okay. So how long have we got left on that? Okay. I think we could finish default arguments. So default arguments and function overloading. So it's best to put your default arguments in a header file. Default arguments and function overloading. Functions with default arguments may be overloaded. Functions that have default arguments may be overloaded. For example, the following is allowed. So I'm going to do that myself. We're going to do include preprocessor, again, input output stream, and then again the preprocessor of include, and we're going to do string view, and then we're going to have void print standard string view sv or s, and then we're going to be printing standard character output s, and then we're going to do a void print char c equals an empty string, or a string with a space, a character with a space, and we're going to be doing standard character output c and then a line break. Then in our return type int for our main function, we're going to be doing print hello world. As you saw there, we had print c. Then we're going to do print again, print, and then you see here we have an option of c for char, or we have a string literal, and that's how we're able to do both c, or in this case a, and that as well, despite the fact that we've done a default. So this will print hello world, and this will print. So let's see if that's correct. There you go. So you got hello world, and then a space. So it just goes to show you that default arguments are mutatable and they're not completely fixed, i.e. they're variable and yeah, they're variable. Nice. Now consider this case. You got void int, void int x, and then you got that. Okay, so the last few things, and then we'll call it a day there. Default arguments can lead to ambiguous matches. Default arguments can lead to ambiguous function calls. So you've got a void function, void foo, int x. Okay, that makes sense. So what will it go to? It needs to, here's a slightly more complex version. So you got a void print int x, signature print x, void print int x with a default argument of 10. Then you have a void print int x double y. So this will resolve to this. That makes sense. This will resolve to this. And this is an ambiguous. So what will it actually print? Let's have a look. So we got a preprocessor of include input output stream. We have a forward declaration, which is, remember, where we should ideally put our default arguments. So print int x. So these are our forward declarations. We got a void print int x int y equals 10, and obviously a void print int x double y equals 20.5. Then in our return type integer for our main function, we will print, and as you can see, we have three options. First we'll do 1 and 2, but as you can see there, when we were doing it, it then said, well, we can either do that, but we wouldn't be able to do that. So 1, and then we'll do 2. As you can see, then it changes to int. Then we do print 1 and 2.5. As you can see there, we've now changed to int and double. And then print, this will be interesting, print no instance of overloaded function print matches the argument list, because we have 3 overloads that we must conform to. And then as always, we will return 0. So we get a compile time error. And finally, default arguments don't work for functions called through pointers. And we're not doing pointers at the moment, so we'll leave that there. Okay, cool. So we left off at lesson 11.6, function templates. So what I'm going to do now is, as always, just a quick summary of what we've done previously. So we're on day 23. Does the stream actually say day 23? I just want to make sure. Where are we? Yes, it does. Okay, cool. So what did we do? We did intro to function overloading. Intro to function overloading resolution. Making a function overload compile. Overloading based on number of params. Params, types of params. The return type is not considered for function for differentiation. Function overload and resolution, ambiguous matches. Resolving overloaded function calls. The argument matching sequence, i.e. the various steps that we go through, the 6 steps, or that I say we, it's more the compiler. Ambiguous matches. Resolving and resolving them. Matching multiple functions with multiple arguments. Deleting functions with the delete specifier. And then default arguments. And I think that was the main thing, when to use them. And when to use them. Multiple default arguments. Default arguments cannot be redeclared, so it's best to use them in forward declarations rather than definitions. and default arguments can lead to ambiguous matches. Cool. Tutto bene. And today's date is the 21st of August, 2026. Cool, nice. So that's going to be it for today. If you're following along, nice. Hopefully you enjoyed it as much as I am. And I'm going to leave it for today. In the next one, we'll obviously be doing function templates. So that'll be interesting. It's something completely new. You can, as we saw, we did a bit of templates in the arguments. But yeah, looking forward to that. So as always, leave a comment, subscribe, leave a like, all that good stuff, and I will see you in the next one. Bye.